CHEM 2212. This is the Friedel Alkylation lab. We've got our starting material, our 1,4-dimethoxybenzene. We've weighed out 690 milligrams here. We've got 1.5 mils of our unknown alcohol, KTT26Q18. That's written on our data sheet. We'll show that in just a second. And we're going to combine that into our Erlenmeyer flask with our glacial acetic acid, also 1.5 milliliters. Here's our glacial acetic acid. Very strong odor, so we're keeping our snorkel in place here. So we're going to mix that just a little bit here. Now, as of right now, these components alone are not going to react. We're going to have to add in our sulfuric acid, but the first thing that we'll do is place it in an ice bath before we go get the acid out of the hood and bring it back over so that we can add it drop-wise. We've had our initial reaction solution cooling in our ice bath for a couple of minutes. Now we're going to go ahead and add our catalyst, which is 1.5 mils of sulfuric acid. I'm going to tilt this to the side here. And we're going to add this dropwise. This is an exothermic reaction, like a number of the reactions that we've seen in our past videos. We just want to make sure that it doesn't overheat. So we'll do this slowly and on our ice bath, and we'll move it over to our hot plate. And I'll do a couple of drops, and I'll make sure I stir it, and we'll just proceed cautiously. So far our temperature is under control. We've got a light, I don't know if we can see that very easily, but we've got sort of a pink hue to our reaction mixture. It started out clear, so we're pink and transparent at the moment. Last couple of drops, and then we're done. Oh, no, we got a little bit left. Got to make sure we get everything. We had 1.5 mils. I want to make sure we get it all in there. But we've added it slowly enough that I haven't felt any real temperature change here. It's nice and cool. Swirl it a little bit more in our ice bath. And now we're ready to move it over to our stirring plate. I'm going to introduce the stirring bar. And we're going to use that to let this stir for about 10 minutes. Try and get it centered as best we can. We'll come back and check on this in about 10 minutes. Our reaction has been stirring for about 10 minutes. We've got sort of a pink slurry at this point. So we're going to take this over to our ice bath. We need to quench the reaction. We'll place it back into the ice bath. And then I'm slowly going to add 15 mils of ice cold water. And I'm going to stir a little bit, add a little bit, and then stir. You can see some of that slurry starting to break apart. Our spin vane is free now. Still got a little bit more. And that's the last of our 15 mils of water. We're going to swirl this and hold it in the ice bath for a couple of minutes. We'll do a quick check-in on our data sheet, which is over here to our left. We've got our unknown alcohol code. One of the data points that was not on our sheet originally, the initial volume of glacial acetic acid, 1.5 mils. The initial weight of our 1,4-dimethoxybenzene, 0.695 grams. The initial weight and volume of our unknown alcohol, and the amount of sulfuric acid, concentrated sulfuric acid that we used. While this is cooling, we'll get ready to filter it using our Buechner funnel. All right, so we've cooled our solution. We've got our crystals. We're going to go ahead and filter this on our Buechner funnel. This is our Crude product. We'll wash it with DI water and ethyl alcohol. I'm going to go ahead and wet my filter paper. Turn on my vacuum. And we'll see what sort of product we've got. Looks like we've got fine white crystals. I'm going to use 5 mils of DI water to rinse out our flask. Try and get as many of the crystals as we can out of here. I'm leaving my, I don't know if you can see it in there, my spin vane is still inside, so I don't want to dump that into my Buechner funnel. I'm now going to measure out 5 mils of ethyl alcohol, roughly. Introduce that into our reaction flask. We're going to rinse that as well. All right, we'll pull air through this Crude product for a couple of minutes, and we'll check back in. All right, so we pulled air through our Crude product we're going to go ahead and scrape it out into a beaker so that we can go through our recrystallization process. See some nice white crystals, but we do see a little bit of discoloration, so it's going to be imperative that we recrystallize this to make sure we've got pure product. We've got a nice amount of crystals. It looks like the reaction worked really well. I'm just putting this into a 100 ml beaker, and then we're going to use hot methanol to recrystallize it. Do everything we can to get all of our crystals out here. But we will leave a little bit behind, and that's always something that we want to factor into our percent yield calculations. Can't get everything. Anytime you transfer from one vessel to another, you're going to leave behind a certain amount of your compound. Okay, so I think we've done pretty well. So we've got our product in our 100 ml beaker. We're going to go ahead and recrystallize it using 10 milliliters of hot methanol. We don't expect all of these crystals to go into solution. Here's my data sheet here, and I'll measure out 10 mils. Go. We'll go ahead and introduce that into the flask or into our beaker. We'll swirl that around and we'll set it on the hot plate. We're going to let it sit on the hot plate for a little while to see if we can't get most of those crystals to dissolve. So we've continued to heat our crystals and our methanol, and as predicted, we didn't get all of our crystals into solution, but that's okay. We're going to get most of our impurities to dissolve, and then we're going to go ahead and take this over to our ice bath. It's warm to the touch, but not hot, so we can go ahead and set this in carefully. We're going to give that a couple of minutes to precipitate, and then we'll collect it on our Buechner foam. Okay, so we've taken our Friedel Crafts crystals off of or out of the ice bath. And they're looking pretty nice. And we're going to filter them in our Buechner funnel setup. I've wet the paper with a little bit of DI water, put a little bit more in there. I'll attach my hose, turn on the suction, and we'll be ready to collect our crystals. And we left a lot behind, so we're going to rinse it with a little bit of water to make sure we catch everything. And we'll keep doing that until we get all residual crystals out of our beaker. That's our last little bit. We'll let air pull through this apparatus for about 10 minutes to dry everything thoroughly before we put it in our drying oven. and then we'll obtain our final product weight. So we finished pulling air through our product crystals. They're looking fairly dry, but we know that there's still some moisture in them. We did use water to rinse them down into the Buechner funnel. So we're going to scrape them off onto a watch glass, pre-weighed. We've already got that written on our data sheet that we'll show you in just a minute. But we'll go ahead and get these scraped out, and we'll put them into the drying oven for a little while. They're coming off really nicely though. These are fluffy white crystals. We'll just get everything that we can off of our filter paper here. We don't want to leave anything behind if we can help it. Oops. Don't want to take my filter paper off if I can help it. All right. And that is basically everything that we had in our Buechner funnel. So we'll take these over to the drying oven and we'll let them dry for about 10 minutes at 60 degrees, and then we'll come back for the final weighing. We've been drying our product crystals for a few minutes. We'll go ahead and take them out of the oven. We'll take them over to the balance to weigh them out to get the mass of our final product. Oh, let's make sure we tear it out first. Okay, 48.176. And I'm subtracting out the weight of the watch glass alone, which is 47.453. So we've got a total of 723 milligrams of our purified product. There's our data sheet so far. The next thing up is our melting point. We'll come back. Okay, so we finished our melting point determination for our final product. Our melting point range was 99 to 101 degrees Celsius. We're going to use that along with the IR and NMR provided on ELC to determine the identity of our unknown alcohol starting material. Good luck writing up your lab report.